Hello and welcome back to compiler programming. A couple of episodes ago, when dealing with polymorphic functions, we implemented these two functions that return to us the size of an argument that is passed to it. And because of overloading nature, we could call one or the other depending on the argument that we pass, and that way we could technically at runtime get the size of an argument, sort of. And this is a very limited kind of sort of static form of more generic approach called reflection, where at runtime you're able to get information about the type that you're manipulating. Again, in C, it's very limited. You basically only have this size of keyword that allows you to check what is the size of a particular type or instruction. So if you don't know, you can write something like U64 size whatever is size of, for example, U64, and it will tell you what is the size of that. But you could also for example, ask what is the size of array of 1,000 these, or you can then, I don't know, access some array index and ask what is the size of that. So there is generally, like, you can put either expression or a type in here and it will tell you the size. This is very, very limited, and even in C++ up until very, very recently, and I'm not even sure it's released, you didn't really have any good way to, for example, iterate over all the fields of a struct or understand what are the arguments of the function. And I think this is very, very limiting. It would be nice if in this language we had opportunity to do so. So how does it work? Let's again start with a small test and think of how we would like this to be in terms of the API that we want to have. So since we want to have those values at runtime, that means that whatever will be the result of the reflection will need to be a value so that we can make some kind of manipulations with that. So obviously we will have value star, I don't know, let's keep our size of as 32, and we would say, let's say we add this size of macro, and then we pass some value to it. Value from S64, or since set 32, we say 0. So size of now becomes this feature of the compiler that allows us to implement something similar to what C has, but we would later extend it to be more. So we say like this, and then we need to somehow check what is this thing. Since we want this to more or less be compile time known, then we expect that the size of S32 would actually be an immediate, right? So this is the first test that we can write and say that check, well, first of all, we need to employ our overload thing, because now everything is can be multiple overloads, and I might be slightly already regretting doing this change early on. It might have been better to do it later once we have more features, but it's fine. We'll figure out what is the annoying part and maybe make it easier. So say overload of size of S32. We naturally check that overload is there, but it should be. And then once we have an overload, we can check that the overload operand type is operand type immediate, and I think it should be immediate 32 because they can be quite big types, and we want to guarantee that all of the sizes of all of our types will fit into this thing and will always be the same one. We could actually make use of overloads here and like make this value be multiple things if the size is smaller than a certain amount. Like if the size is smaller than 255, we could actually create two overloads. One of them will be S8, the other one is S32, but I don't know. Let's just keep it simple for now. And once we know that this is immediate operand, we can actually check it, right? We can say operand immediate 32 is 4. This is what we expect. Obviously, we have a problem that our code has no freaking idea what size of is, so we need to conjure up a thing that would do this. But interestingly enough, we don't actually need to do anything for this because we already have the exact code that would deal with it for us. Now, since we introduced overloads, again, this becomes a bit tricky to figure out. And this is one of those things where, as I said in that episode, once you introduce overloading into a language, you have all of these very weird corner cases. So, and we are running into one of those. Let me explain what I mean. So we have this size of, and we put size of value, and we want to get this size. Before we dealt with the overloads, we would just do this. Descriptor, byte size, value, descriptor, right? And this would be it. We would know exactly what is the size of whatever we pass to here. And as far as types, so we in C we can't really do detection on the macro whether we pass descriptor or value. So let's say that our size of always expects a value. We could also create a separate one that will be size of type that would expect a descriptor and then return to us what is the size of that descriptor. So let's actually start with this one. So we say size of descriptor and descriptor. But in a sense, it's a bit meaningless function because it just proxies it to the other one, but let's keep it for consistency. Okay, but getting back to our size of value, as mentioned, now we need to make a decision. What is actually supposed to happen when we don't know, when we have multiple overloads? And I guess I will just say that when you ask size of and you have an overload, then you will have an error if you do have more than two things, or if basically if the size of overloads is not the same, then you would get an error. And if it is the same, then everything is fine. This means that it will naturally work for what we use it right now, which is function overloaded, but it will not work for stuff where you start to mix different types. We could make a different decision. We could say that it should return, for example, the largest size, but these are the subtleties that need to be dealt with. Value byte size, value. So now we need to implement this new function called value byte size, and we can do it this way. It's supposed to return to us, actually, here it's also slightly different. It should be value from S32 descriptor byte size. It should be like so. And here we say value star and sort of do the same, right? We say value overload star. Overload is maybe get if, actually, no. As I said, we will do something slightly different. So we say we need to iterate over all of them and figure out what the size will be. So let's say S32 byte size is 0, and we say for S32i is 0, I is less than, so here we obviously have value overload count plus plus I values overload star. Overload is value overload list I. And now we can actually say that if, so we want to make sure is that all of the sizes of all the overloads that we're trying to check are the same. So if byte size is 0, which means this is basically the first one, or we can do more explicitly, I guess, saying if I is 0, then we just say byte size is the descriptor byte size of overload descriptor. This is pretty straightforward. Otherwise, we say that also do the same. Actually, let's bring this up over here and do it this way. So if we are on the first iteration, then we just simply assign this stuff. Otherwise, we assert that byte size is the same. And then we assert that byte size is not 0, essentially, and return value from S32 byte size. So we just taught our compiler how to create a value for the right byte size. Let's see what happens when I try to run this. We have some issues here, which is very, very strange. Let's start with here. So obviously this is supposed to be like this. This is like this. Okay. Value from S32. Undefined assume, yeah. So for now, let's just move this down. Okay, I guess that was it. Yeah, sometimes C errors are not the greatest. Let's just say that. Okay, well, it compiled. Let's see if it at all works. It does. We have our thing. and we say should support size of operator on values. We can do the same for types on descriptors, and we can say size of descriptor, say descriptor as 32, and will be exactly the same thing. So let's run that as well, and it passes just perfectly. Okay, so this is good. We now have a neat thing where we can, inside of our program, at any point, we can just say, what is the size of this thing? It's not a full-featured, how can I say? It's not completely the same thing as in C, because in C, it will not evaluate code that is inside of here. So like you can put an expression there and it will just like pretend to evaluate it and to know what is the type of it, but it will not be in the output of the compiler. Right now, we don't really have that option for us, but it could technically be implemented where we just kind of create a point in the encoded bytes for the function, and in our function builder say, okay, now you operate in a special disabled mode and you don't actually output code, but you still do all the operations, and then we clean up all of these operations and just get the return type. So like this is something we could implement. If it sounds interesting to you, I could maybe do an extra episode about this or something. I don't know. Okay, now what I wanted to do is hopefully a bit more interesting and a bit more challenging as well. And what I want to do is have an ability to get all the for example, have an ability to list all the struct fields. Now, right now, our structs don't even have field names, which is something that we will need to fix now. And we can do this. Should support reflection on structs. And this one will take a bit. We will create this macro that says reflect. We will need to, we will need to mark this so I can quickly jump to it. And I want to find where we do struct. So this seems okay to me. We have this struct builder. Good. Now we need a struct. So the first thing is struct add field is something that we will need to change to take a name. And right now I will just use regular C strings for the name. So we'll just say const char name. Nothing really fancy. It's not defined here, it's defined in here, I guess, or maybe even in here. Where are you, struct add field? Okay, it is in here. Good. We now need to add const char star name. And we save that name in the field. Nothing fancy at all. Builder field struct field name is name. Okay. We have now a bunch of errors, which is fine. What is happening here? Yeah, it doesn't know what the hell reflect is. That is okay. We don't need that for now. But here we will need to provide a name. And for these tests, it's absolutely unimportant what the name actually is. So we will just add X as a name. Here we could add something better. We could say width and height. And it's much better. And this is, I think, a dummy field that we just use for testing of the offsets. Okay, so this is good. Before we implement reflection on structs, actually, no, it's fine. We can keep it this way. Okay, so now we have a struct, and we say X, and we say Y. So this will be like a point, and we can say descriptor point struct descriptor. Good. Now we need to create a value for this descriptor. Let's, how shall we do it? Well, I guess we will need a function to check our efforts. So let's do function check reflection. We create a variable on a stack called struct. Yeah, let's call it struct underscore. That seems fine to me. Now we need to provide a type for it, and this is an interesting part. So the type of it, the descriptor of it will be descriptor struct reflection. So we'll create a special descriptor that will describe the layout of the fields in the struct. You will see, if it doesn't make sense, you'll see in a moment what I mean by that. And then we need to assign something to it. And for assignment, we will need to say reflect descriptor to keep with naming convention. And so it's going to be reflect. And we provide this point struct descriptor. Okay. And let's start very simple. And we might not even need the field types. I was going a bit ahead of myself. Let's start very simple, and let's have this function that returns the number of fields in a struct, but it will do so statically instead of dynamically. So we expect basically this thing again to be immediate. So maybe we don't even need to do this. No, we do. We do, because we need to access a field of a struct. Like this by itself will return this descriptor, right? And that means we will need to do some more manipulation on our structs. And right now, I believe they are not very nice to work with. Where is our test for structs? Yeah, this is a bit yikes. Let's just put it that way. So maybe we first clean up this part before we jump into reflection. But let's set up the test regardless, and it's fine if it will be half done. So this is okay. Let's get these to compile. So obviously we don't know what the hell is descriptor struct reflection. Let's make it happen. So we have these descriptor S32, 64 for known things, and now we will need to add another one. Actually, we'll need to add more ones, but right now I'm just dealing with structs. Descriptor struct reflection. what is it? Well, it is actually a descriptor type struct by itself. So this is a bit of a mind-bending moment if you're not used to this kind of stuff. And it will have fields that describe to us some of the aspects of the type that we are trying to inspect. If we look at this descriptor, where is our struct? So we have this stuff. We have field count and we have a list of fields. And right now, as I said, I will focus simply on the field count so that we can get to this. So we will need to add a struct field to our thing. So we basically do this static construction of a struct descriptor. Descriptor struct field struct reflection fields. This is an array, and the field will be what? The name of this field will be argument count. Okay. Then the offset will be 0, and descriptor, we will need a descriptor, but we already have one. So offset is 0, and descriptor of this is, what is the type of it? S64. Probably should be 32. Let's do 32. And then we just say descriptor S32, right? So now we have a field descriptor that describes a field of whatever the reflection object is going to be. It will tell us what is, sorry, it's not an argument count, it's a field count. This is a field count. Now we have this stuff. It is a type this. And then we say struct. Is it called like that? It's called struct. And inside struct, we now have this again, the same thing. We have field count, which is static array size of this array. And we have field list, which will be, well, this array. Is this fine? Yeah, that seems correct. So we now have a descriptor that will tell us what would be the result of that reflection. And I forgot the semicolon. Good. So now we are just left with the fact that it has no freaking idea what reflect descriptor is. Okay. And in reality, reflect descriptor could return us multiple things. So it should be like we should be creating a descriptor for this type, but it's a bit tricky right now for us to express this well. So right now I will cheat and assume that whenever we ask it to reflect something, it is just a struct. Otherwise, this episode will go forever, even longer probably than yesterday's one. Okay, where is our definitions? Let's put them here and say define reflect descriptor. And we will need a helper function. I mean, we could actually turn this into function named this, but I rather keep it macro. It's fine. Reflect descriptor, and it wants our descriptor. Good. We have that. We go to our value, and we are ready to deal with stuff. So we now know what it's supposed to look like, but we need to now create one. So this is supposed to return a value, remember. It will get a descriptor star descriptor. Let me scroll a bit so it's easier to see. As I mentioned, right now I'm just gonna say that descriptor type must be descriptor type array, and add a fixed me around this. Oh, sorry, not array. What am I thinking? It should be struct. And we add a fix me. Support all types. Okay. Now we need to create an actual reflection struct, and this is where the lack of reflection in C is also playing by joke on us, because we need to also describe the object that we just described here. We also need to describe it in C terms. So we do it like this: descriptor struct reflection. And again, we need to do it like so. Actually, yeah, we do. Even though we have, so one question you might be asking is like, well, wait, we have already this descriptor struct. Why can't we just point to it? And I guess we could, to save some time right now. In general, it's not a very good idea to give to the program exactly the internal representation that the compiler is using for its own things. Like you usually want to map those, because if you want to provide a stable interface to your users to consume this API, it would be quite nasty if with every change of compiler you like suddenly had different things given to you, which is very bad. And other extreme is also bad if you keep the same things and suddenly you can't change the compiler. So like it's just generally a good idea to have a boundary in there. But maybe for now we'll just ignore this and not really do it. But that would mean that I need to do this exactly out. No, we're gonna do it. We are going to do it. So we can also add another volatile reflection, and this needs to match basically this thing, right? Needs to match what comes after. Okay. Now that we have this, we can now actually deal with it, which I already forgot where we are. So we have this type defs. Oh, wrong button. Struct. Here it's okay. Reflect descriptor. Did I start to work on this function? Yeah, Oh, yes, I did. So we need to create this actual C object that we can refer to. And we say reflection is temp allocate whatever this is. Now, so we have a descriptor and we now have this reflection object, and we can just do pretty boring assignment. Descriptor field count, right? And we need to return a value to our to the color, and that value would be a bit more involved than usual. So we say value star result is temp allocate of value, or let's do value overload, and we just wrap the overload in our regular function. So single overload value of result. Okay. Results. Now we need to shove some things into result. The first thing is the descriptor of this will be descriptor type, descriptor struct reflection. So the returning value will be whatever this is, and operand is in memory. So this is going to be this complicated operand. Is it like memory indirect? Let me think for a moment about how I want to do this. So the issue here is that we need to store this somewhere, and we don't really have a way to address this nicely, what I'm trying to say, because we need to store the pointer to this object, but right now if we look at our types that we can have, it is these immediates and memory indirect, and what we want essentially is just operand type memory that is an immediate. And this addressing mode does not really exist, I guess, in the x64 assembly. So we will have to do memory indirect. Let me check how I do it with the other struct that we are dealing with. Memory indirect, RCX register. Yeah, so I'm I'm cheating here, and I'm doing this kind of stuff where I essentially shove the value in there and just say, well, that's what it is. This is a bit unfortunate. What can we do? Well, let's create a new type. And shall we create a new type or not? No. The way we're gonna do this is change some things around. We will now move this to function builder, function begin. Okay, these are all our function stuff, function arc, function return. And we will do function reflect. It will accept a function builder. Okay. And it will accept this descriptor, same as the other function. But it will do some different things. So this will just solve our problem with where to put this. We'll just put it on a stack. And right now it's going to be even fine because it's a very, very small struct. In later iterations, this probably is not going to be great because you don't want to like put these big structs on stack for each of the function that tries to do reflection. You want them all in memory in one place and deduplicate them, but it's okay for now. What does stack reserve return? I believe stack reserve returns value overload star reserve stack. Am I correct? That's my reserve stack. And so this means we can do it this way. So our result will be this stuff. And we will put yes, and then descriptor struct reflection. Let me just think of it for a moment. I will put it on the stack. That means that the operand for the whole struct will be just okay. Operand type. No, it will be done for us, right? So if I check on what reserve stack does, sorry, so here it does this, it creates an operand, it creates an overload, and it shoves this stuff into there. Yeah, that's okay. We don't even need to do anything special for this. And for struct fields, then we would be able to deal with that. Okay, that's fine. That means that we just need to provide this stuff. So it needs to reserve stack for this struct reflection, but we still need to actually put the value there, right? Because we created a space we can refer to, but we did not do anything meaningful with it. And so instead of this allocation, what we will do is we will just say, we'll add another fix me where we figure out, like, right now I will just know that the zeros field in struct is the right one, and I will just write directly to that place. But long term, that's not sustainable. So fix me, do support generic allocation of structs on the stack. Okay, for now though, what we will do is we will say move value result wait a second. descriptor, where are you? Okay, we have field list, field count, that's good. So we want to kind of create a fake descriptor for this first field and move it there. Or not even descriptor, because it is just operand. So let's just do this. Move value builder, which we don't have yet. Put builder here. Do it like so. Result operand value from S32. Descriptor struct field count. Okay, something is not right. Using types specifier, blah blah blah, function, compatible types. Yeah, that's fine. Here we need to pass descriptor. Okay, move value from S32. Yeah, let's just say instead I will do like this. Right? So I think our reflect descriptor is slightly broken right now, because what it needs to do is it needs to say function reflect of builder and descriptor. Good. Descriptor and declared identifier. Okay. Cannot convert from operand to value overload star. Yeah. So it should be value star, I guess. That's fine. Syntax missing. Did I miss a brace somewhere? Before identifier function reflect. Okay, something is really wrong with this macro. So let me just write this out manually, and then we will see what is wrong with this. Okay. Move value cannot convert from operand to value overload star. I guess our move value now expects overload, so we just do maybe get if single overload and put here what? This value from S32, this. Wrong button again. Cannot convert from value star to value overload star. And which one is value overload star? So this is reflection, and I guess this is value star. Yeah, I'm starting to really regret the change, but it's fine. We will survive this. Okay. We are compiling, and I want to at least run this function to see what is happening, and then later we will try to check. Or we can, yeah, let's just first try to run this. It's called call function value. No, we need. Where are you? Value as function. So we need this. Let's put this here. S32 result. Actually, there is no result at the moment. So we take field count. We say function type S32, or actually function type void to void for now, because it doesn't even return anything. And we just try to run this and see how terribly things explode. Okay, well, nothing really happens. It's already a good sign. Now we are ready for the main event. So what I want to get out of this function is value 2, right? So we have 2 fields. So I expect to be able to do something like return, and we would add a macro called field. So we expect this to be a descriptor. I say that field of struct field count. So we should be able to now look up fields by name, and first implementation will be ridiculously inefficient, but this is fine. So, and that's about it. For now, I will comment this out, and instead maybe, no, let's do this way. We do the fields. Again, we will need a macro, and we will need to have a helper function. Let's actually start with a helper function before we jump into the macro stuff, because we had issues with it just now. Let's make it as easy on ourselves as we can before making it pretty. And I already lost where I am. Where are you? Reflect. Okay, sorry about that. And we say struct. So we have struct begin. Let's create struct get field, I guess. Struct get field, yes. Struct begin. Where are you defined? Struct add field, struct and struct get field. What do I expect to get out of this? Well, I expect to get out of this a value. We get also a value, struct value, right? Then we do the standard dance of now overloads maybe get blah blah blah. Maybe I will just simply create a function that does this assert. So like assert and get if single overload, and that will already be nice help for us. Okay, assert. Then once we have this overload, we need to have another assert that says that this struct overload is the type of this, or the descriptor type is descriptor type struct, because otherwise we can't really get fields. Now at the very end we will assert could not find a field with specified name and return 0. And in the middle we just set right now quite inefficiently. We will just iterate over all the fields again and check what is the name of each of the fields. I can do descriptor star, so it's just a bit easier on us to write all of this. Descriptor struct field count plus plus I. Where are you? Oops. Oh. Apparently I can't type I. Okay, and we say descriptor struct field is descriptor struct fields list I. Okay, and we say if strcmp field name, well, we also need the actual name, right? So we add it here, say name, and should not forget that strcmp actually returns 0 if they match. So if it is a match, then what we do is we create a result. So value overload star result is implicate value overload. We have an operand, and this will be this a bit tricky version, because what we will need to do is we will need to take the operand of the struct and then add offset to it. And there will be also different versions where like if struct is for example in a register or something, then we have issues. But for now we'll just edit fix me support more operands. And for now what I want to do is I want to say struct assert that struct overload actually, yeah, struct overload operand type is operand type, oops, operand type memory indirect. Because again, if you don't remember from previous episodes, the way struct fields works, we have some kind of base pointer for our struct, and fields are just some kind of offsets. So the first field will be, so our field count is struct plus 0, and if you had more, we would have like struct plus 4, for example, and so on and so forth. So this means that if our struct is already somewhere in memory, we can just copy this operand, and we will do just that. We say operand is struct overload operand, and we can now slightly simplify this stuff. So we assert that, and then we do operand offset plus equals. Actually, we know field offset, or yeah, exactly. We add this. Now we have operand to play with, and we, as far as descriptor goes, this is also easy. It is field descriptor. And return single overload value of result. Keep pressing Command N. What is wrong here? Points to struct. Use arrow. Offset is not a member of operand. Is it called displacement? What is it called? Operand. Where are you? Yeah, I should do indirect and then displacement. Okay. So where is this? Operand, indirect, and then displacement. Okay, that's better. Here we need to say const value overload. It's good. Descriptor struct and descriptor struct. Oh, okay. So looks like now we can get the field by name. Let me mark this as well and see how it goes. So if everything is great, then we now change the type of this to this. We say S32 count is this stuff. We call this and we check that count is 2. It compiles, but let's see if the tests tell us the same thing. Wow, I didn't even make a single mistake. That's very suspicious because that happens to me for like second episode in a row where I type a lot of stuff and it just works. So, but I guess it works. I do want to show you the assembly of all of this because it might be easier to follow actually what was happening there rather than in what I was typing. Here we go. Start. We skip over this, we jump into here, and we look at some stuff. So, what is happening? We have our struct reserved on the stack, so this is why we see 18h instead of 8h. Like if our function had no stack reservation, it would be 8h for the alignment. This is us kind of taking that known compile time value and putting it into that stack location where we say will be our reflection struct. Then we move things around a bunch. What is it actually doing? That's very interesting. It like moves it there and back again for no real good reason, but that's fine. Okay, now I remember. Yeah, our return now, whatever I clicked, our return now creates a temporary value. Yeah, that's all perfectly fine. So we create a temporary value and we put stuff in there, and then yeah, so we move this into EAX, we move this into return value, then we put it back into EAX because EAX is a return register. Yeah, all looks good to me. We have it working. And now we have a solid base, not only to extend this, so like you could imagine, not just field count, we could add field names, we could easily add offsets to that thing, we can extend it to other types. All of that is now very, very easy to add, and maybe something I will do off video, maybe something we will do later on video. Let's see how that goes. One thing I will do is I will update all the code to use this stuff, so our tests are nice and concise. Okay, let's take another look at our tests. Everything is great. I guess that's it for today. Thank you very much for watching, and hopefully see you next time.